All right, so I'm Josh. Thanks for the introduction, Marcus. Want to go through just some tips and tricks. So a quick session on some practical things that might help when things go wrong with your GNU radio blocks. So, a lot of times you'll make your own block, you'll think everything's great, run it in GNU Radio Companion, and just nothing, right? Say, you're early in the process, you haven't added good logging, you don't have good exception handling. So what do you do? So this is where you want to get to the debugger. Now, for this talk, primarily focused on C++ blocks and runtime errors, so not necessarily compile errors or linkage errors, anything like that. So standard approaches, of course, the best is good exception handling and logging so that at runtime you can see everything. The block API has a logging mechanism, which we'll go over briefly. So every block has a very easy way for you to just either dump to a file or dump to standard out. And that was very recently updated in the 3.9, 3.10 releases. You can examine core files when there's some sort of seg fault, or what we're probably going to spend most of our time here is how you hit breakpoints. So who here uses Visual Studio Code? All right, so about half people. So started the last few years, really, this has become my tool of choice, and being able to debug GNU radio blocks in here, hit breakpoints, it's embarrassingly easy. So we'll just go through the basics of how this is done. So when you're in Visual Studio Code, say you've compiled everything with your debug symbols, there's a little button on the side that you create a launch.json file. It's very apparent, and then you add a configuration with GDB launch. So the only two things that you have to do in that file is set the program to Python. Say this is a Python flow graph. If it's a C++ flow graph, the name of the program is your compiled C++ flow graph. If it's a Python flow graph, program is Python 3, and the args is wherever the rendered flow graph from GRC is. So GDB is very straightforward. It takes your current environment, whatever you launched Visual Studio Code with, if you're using some custom prefix. If you're using LLDB, which is another plugin, this requires that you set that environment in that JSON file. And so we'll show an example of that. So here's a little example of setting that up. So we go over here, click that, we're going to debug, create a JSON file if it doesn't exist, C++. Now we're going to add a configuration, GDB launch. I know that was very quick. So we'll go back. Let's go a little bit slower here, I'll pause. So we debug, create a launch JSON file, C++, and then we add this GDB launch. Okay, so it populates all of this stuff for us. We're going to add as the program name, user bin Python 3. Now, this is on Linux, of course, and then the args is going to be the path to the flow graph that was generated here. So we're just going to copy this and paste it right there with quotes. All right, and now all we have to do is run start debugging, and it's going to go. I don't even have any breakpoints here. I just have a program here that's going to seg fault. So what happens, we wait a little bit, it runs. It's loaded up all of our threads here. The threads are running. They're caught by the GDB debugger. Oh, and it found our seg fault. So we know now where the crash was happening. So that not much we can do here. We can fix that problem, go back, try again. Let's see. Now, if you want to step through with the GDB debugger, there's a few caveats. One, anytime you're compiling with debug symbols, with debug, no optimization, it's going to kill any runtime performance because there's no optimization. And then with the GDB plugin, if you try to step too fast, it will just disconnect and crash, and you'll have to restart. So if you want to view the contents of the arrays and the pointers, over in the watch window, there's just a simple syntax. You do star, pointer, @, and then the number of elements you want to display. So we'll see an example of this. Okay, so now we're going to GDB launch. We're going to set our breakpoint. Start debugging. Now this goes on for a little while. The GDB debugger is pretty slow for it to catch up, but I will speed this up. And it catches the breakpoint. So now we can go over to the watch window, and we want to look at the, let's say we want to look at the output pointer. We put star out at 10. It's unpopulated. And then as we step through this for loop, it's going to populate that. You see it right there. I think you can even change values. That's what GDB will do. So this is much, much easier than debugging used to be, say, with like Eclipse or if you're using command line GDB. So, you know, our goal is to make developing blocks as easy as possible, and, you know, just bring in, you know, and educate whatever tools we have available to make it as easy as possible for people. So the code LLDB plugin, won't go into too much detail. The only difference is that you have to load up your environment variables in the JSON file, and there's also a different syntax for viewing arrays. But this one, if you're having trouble with GDB, this one can be quite a bit quicker. It doesn't seem to crash if you step through too quickly. Now, Python scripts, the top level script that gets generated from GRC, this is very easy to step through. All you have to do is select Python current file as your configuration, set your breakpoints, run, and step. And then you can, there's an interactive Python console in the debug, and you can, you know, type stuff in. You can launch matplotlib plots, do whatever you want to do. So this one, so we're going to switch over up here. We're going to open up what got generated from GRC. We're going to switch over to our add configuration, Python, current file, and we don't have to change anything. Switch back over to the Python file, set a breakpoint, and start debugging. And this one's very quick. Hits the breakpoint, and we step through. So this is not a Python block. This is just your top-level script. So if you've got a, say, a vector sync or something, you can hit a breakpoint, plot some things at the Python level. All right. So debugging Python blocks is more complicated. The reason for this is the way this is integrated into GNU Radio. The GNU Radio runtime, all written in C++, has an embedded Python interpreter that that calls out, you know, this is using PyBind 11 magic, and it calls out to the Python block work methods. So you can debug it. I've gotten it to work once, sort of. And the way you get this to work is by using the debug py package. So you can, in your block, you can import the debug py, and then you attach to it. So rather than launching the debugger, you run your flow graph, and then you'll attach to it. So I don't have an example of this running, but you would have to launch your flow graph using something like this command, where you call debug py, launch your flow graph, and then in Visual Studio Code, then you're going to have an attached to process. And the process ID would pop up, and you pick that one. And it's a little finicky, but it's doable. If someone figures it out, how to do it robustly, please write something up on the wiki. All right, now core dumps, you know, if you don't want to bother with Visual Studio Code, you have a whole nother tool chain. You can examine your core dump very easily. All you have to do is include your debug symbols. And on Ubuntu, you have to type, before you run your script, ulimit -c unlimited. And then run, wait for the inevitable, and then your core dump will show up in, you know, different distributions, put it in different places. Ubuntu 22, it throws it into this directory, and then all you have to do is GDB, Python 3, and then the name of this nasty file. And then it'll show up and show you the whole call stack where it dumped. So example of that we won't step through. I think we've got a logging. So Marcus redid the whole logging system in 3.10, and each block has an object natively in it that, that all you have to do is say, all you have to do is edit your config conf, tell it that you want debug logging, but every block has this dlogger object that you can just say, rather than doing printfs, because printfs are there permanently, you can't just turn them on and off at runtime. All you do is you say, my logger, I'm going to log at info level, and then it's FMT style formatting. So when we do that, we can get, say we're logging to standard out, or in this case, we're logging to a file, I think. Here, we're logging to a file, so that'll be better at runtime. Then we can examine the file, and we see everything. And so those are great. You can put those all throughout your code, and then when things go wrong, you can just examine your logs. All right, one last thing I want to go through, running out of time, is Python snippets. So not so much a debug thing, but if you're not aware of this feature, snippets allow you to insert little bits of code from GRC, so you can do all of your programming from GRC if you'd like. Keep it all in GRC. Quick example of this. I want to replace this Qt time sync with something that's going to just plot a bit of the signal at a very specific time. So I'm going to skip head, and then I'm going to add a head. And so what the skip head is going to do is it's going to drop some number of samples. The head is going to stop the flow graph after it gets some number of samples. And then I'm going to capture in a vector sync. So this vector sync, in order to use the snippets, you have to give the vector sync a name that you put into the snippet. So I'm just going to call it SNK. Skip head, let's skip ahead 3 seconds into the flow graph. And we're going to capture 1024 samples. So now let's do our snippet. So now this snippet block, after it stops, we're going to take a look at that sync, and we're going to plot something. So I will skip a little bit here. I'm going to import matplotlib, and we're going to plot this. The data from everything is in the namespace of self, all of these blocks. We're going to run it no GUI, run it to completion. Okay, now we're going to run it. It's going to take 3 seconds because it's dumping 3 seconds worth of samples. And then it plots something in matplotlib. So there's another debug mechanism, not necessarily at the runtime crash level, but if you see something funny in your signal at a specific time, that can be really hard to catch in the Qt plots or any real-time plots. So I believe that's all I had. So yeah, here's the snippet and the entire flow graph. So any questions? All right.
Well then,
Perfect.
please give Josh a warm hand of applause.